Pre-algebra, lesson 106, roots of negative numbers, negative exponents, and zero exponents. So we'll start off with roots of negative numbers. Right, now this is an interesting thing because I'm pretty sure I've mentioned in class before, it's impossible to find something like the square root of -4, right? Because the problem is that it's a square root, right? And if we were trying to say, okay, well the square root is -2, well -2 times -2 actually equals +4, right? And if we were to say, oh, well the square root is obviously -2 and +2, that's not a square root because those are not the same number, right? So the square root of -4 not possible, okay? But what is possible is cubed roots or fifth roots or seventh roots, okay? So if you remember, if I take a negative times a negative, I get a positive, right? But if I do a negative times a negative times a negative, right? If I have an odd number of negatives, my final answer is going to be a negative. And that's the key here. So what if I were to ask you, what is the cubed root of -8? Does that have an answer? Yes, it does. So the cubed root of 8, which we should have memorized our cubes, the cubed root of 8 is actually -2, right? Because I can do -2 times -2 times -2. I have not changed any of the numbers, they're all the same, and -2 times -2 is +4, +4 times -2 is -8. This works, okay? So you can have negative roots as long as the root is an odd number. Could I do a fourth root of -16? No, not possible, because you can't have even roots of negative numbers. Could I do the fifth root of -32? Yes, I could, right? And I'm going to do a little bit of cheating, but I know that the answer to that is also -2, okay? So if you have odd number roots, they can be negative, all right? So that's the first lesson. Odd number roots can be negative. Now, the next lesson is negative exponents. What in the world is a negative exponent? Well, actually, what is a negative exponent, and what is an exponent to the power of 0? So we know what we know what 2 squared is. We know what 2 cubed is. We know what 2 to the power of 4 is. We even know what 2 to the power of 5 is, right? So let's do this with a chart. We'll explain this arithmetically, using arithmetic, right? So we know what exponents are, right? Because they follow a mathematical trend. That's one of the cool things about real numbers, is they follow math trends. So if I were to find out, hey, what's 2 times 2? Well, you could just say, oh, well, the answer is 4. Well, what's 2 cubed? Oh, well, that's 8. 2 to the power of 4. Well, that's 16. Okay, and you can see a trend here in the answers. If I start at 1, 2 squared, and I want to find out what 2 cubed is, I just take this and I multiply it by 2. 4 times 2 is 8. 8 times 2 is 16. So if I want to find 2 to the power of 5, I could just take 16, multiply it by 2, and get 32. If I want to find 2 to the power of 6, 32 times 2 is 64. Oh wow, that was really easy. If I want to find 2 to the power of 7, 64 times 2, 128. Cool. And the trend continues. Whoops, I'm off camera. Right? Now, what's really cool about real numbers is the trend works in both directions, right? So if I started off at 2 to the power of 7, I wanted to go down, 128 divided by 2 is 64. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2, right? So, and that matches because 2 to the power of 1 is just the number 2. Now here's the question, what is 2 to the power of 0? Well, let's follow the trend. 128 divided by 2 is 64, 64 divided by 2 is 32, 32 divided by 2 is 16, 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2. What is 2 divided by 2? That's the number 1. And that brings us to our first mathematical fact, which is that any real number to the power of 0, so we'll write this as x to the power of 0, x being a variable for any real number, that answer will always equal the number 1, right? Doesn't matter, it's not just 2. This works for any real number, right? So I could, and it even works for variables. So if I were to say, hey, what's m to the power of 0? Oh, that's equal to whole number 1. What's 25 to the power of 0? Oh, well, that's equal to whole number 1. It doesn't matter what the number is. Every exponent to the power of 0 is always going to be the number 1. Right? So we just answered a very cool question. Now, here's the next question. What if I have a negative exponent? Have any of you ever wondered that? What happens if I have something like 2 to the power of negative 1? Or if I have something like 2 to the power of negative 2? Or 2 to the power of negative 3? What happens? Well, the trend, the pattern just continues, right? I'll pick up right here at 1. What's 1 divided by 2? Some of you are saying 0.5. You need to start thinking in fractions. 0.5 is also 1/2, or 1 divided by 2, okay? Because fractions really run algebra. There's more use of fractions in algebra than there are decimals. So if you thought 0.5 in your brain, you start transitioning yourself to think more in terms of fractions, okay? So 1 divided by 2, 1/2. Now what's 1/2 divided by 2? Oh, that might take some of you a little bit more work. Some of you are thinking about fraction circles, but it is 1/4, right? So if I did 1/2 divided by 2, let's see, I'll do the math down here. If I did 1/2 divided by 2 over 1, I would have to invert and multiply by the reciprocal, so that would be 1/2 times 1/2. 1 times 1 is 1, 2 times 2 is 4, 1/4, right? Now, to find out 2 to the power of negative 3, what's 1/4 divided by 2? Well, that's just 1/8. And you see the trend here. The trend is you just take the denominator and you take the denominator times 2, denominator times 2, and that's how the trend keeps going. The other interesting thing to notice is negative 1 is 1/2. Positive 1 is positive 2. Negative 2 is 1/4. Positive 2 is positive 4. Negative 3, 1/8. Positive 3, positive 8, right? So the negative exponents are the same as the positive counterparts, but they're written as a fraction. And this is where we get our rule on how to deal with negative exponents. Right? So the rule for dealing with negative exponents is if I have something like 2 to the power, no, let's not use 2 because we already got trouble. Let's say I've got 3 to the power of negative 3. What I'm going to do is first I'm going to rewrite this negative exponent as a positive exponent by moving it to the opposite location of a fraction. So right now, if I were to write this number as a fraction, it's 3 cubed, 3 to the power of negative 3 over 1. To make it positive, I am going to move this down to the bottom, right? And so then it becomes 3 cubed in the denominator. Now, some of you are wondering, what happened in the numerator? Well, it's just going to be 1. So now I rewrite this as 1 over 3 cubed. I simplify 3 cubed. 3 times 3 is 9, times 3 is 27. So my final answer will be 1 over positive 27. And this works both ways, right? So what if I had 1 over 3 to the negative 3? What could I do there? Well, I'm going to rewrite it as a fraction, but I'm going to move this to the top. So now 3 cubed is in the numerator. The denominator just becomes 1. So that becomes 27 over 1, or just the whole number, or just the whole number 27, okay? So whenever we have negative exponents, the way we deal with them is we write the number as a fraction, then move the negative exponent and its base to the opposite location. If it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator, and then it becomes positive, all right? And let's see here, is there anything else we have to think about with this? Now let's relate this to variables, right? Sorry, this is going to be a little bit of a long video, but you know, there's a lot of important stuff to cover, okay? So let's say we had this with variables. We had to simplify something like, let's say x squared, y to the power of 5, y to the negative power of 2, x to the negative power of 2. How would I simplify this? Well, I start by writing my negative exponents positive, okay? And I can write this whole problem as one single fraction, okay? So if these are negative, they have to go down to the denominator, right? So I'll rewrite this problem. The denominator will now have y to the positive 2, because I changed the sign, and x to the positive second power. The numerator, all it has is the x squared and y to the power of 5. Now at this point, I can start canceling, right? I can simplify this and I can cancel it. That goes away, and then I can say, hey, y5 over y squared, that's the same as y times y times y times y times y over y times y. And then I can cancel out 2 of those, which means I'm left with y cubed. Okay? This is one way of solving it. Now I'm going to show you another way of solving it. Some of you might like this way a little bit better. So let's say, well, I'm going to take the exact same problem. I've got x squared, y 5, y negative 2, x negative 2. The other way of solving it is we can use our algebraic rule for the products of exponents with the same base. Right? So if you remember, if I've got an x to an exponent and another x to the exponent, I can just add those two exponents together. All right, so what's 2 plus negative 2? Oh, well that equals 0. So that's x to the 0. Okay, let's do the same thing with the y's. Right? I've got 2 y's, so I'll just add the 5 and the negative 2. What's 5 plus negative 2? Well, that's 3. That's just y cubed. 0 is equal, x to the power of 0 is equal to 1. Right? So that's just 1y cubed, or y cubed, which is the same answer I got over here. All right? So that's how we deal with our negative exponents. We've got two options, and that is it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.